Okay, welcome to today's daily question. Go ahead and pause the video and give this one a try. And I'm going to go ahead and go through the solution. So between oxygen and fluorine, which of the following has the smaller atomic radius and why? So first of all, oxygen and fluorine are right here on the periodic table. They're right next to each other. Let me redo that so we're not covering up any of these numbers. Okay, so when they're in the same row, the trend for atomic radius is that as we go from left to right, the atomic radius decreases from left to right. Which means that fluorine is going to have the smaller atomic radius because it's farther to the right. So it's not going to be oxygen. So it's not going to be A or B. Now, this might be a little bit counterintuitive if you've not learned about this before, you don't remember this trend. Because, by most metrics, we would think of fluorine as being larger than oxygen. It has a larger atomic number. It has a larger atomic mass. Okay? But the radius is actually smaller. And the reason is related to this atomic number, which is the number of protons. But more protons don't increase the radius, they actually decrease the radius. And the reason is because your protons are in your nucleus, which is in the center of the atom, and they're positively charged. And then you've got your electrons in the energy levels around. Let's just think of the Bohr model. And I know the Bohr model is not totally accurate, but it is sufficient for explaining the trend in atomic radius. Okay, so then, if we want to draw the Bohr model we'll just start with oxygen. It's got 6 valence electrons. So it's going to look like that. So there's an attraction between the nucleus and the valence electrons, because the valence electrons are negatively charged. Opposite charges attract. Okay? So the valence electrons are being pulled towards the nucleus. And the more protons that are in this nucleus, the stronger that pull is. Okay, so the more protons we add, we're pulling those electrons farther and farther inwards, shrinking the radius of the atom. And that's why fluorine has a smaller atomic radius than oxygen. That's why, in general, atomic radius decreases as you go to the right. And the technical term for this phenomenon is effective nuclear charge. So it's related to the protons, the number of protons, but more specifically, it's the effective nuclear charge. So the answer is going to be C. Of course, the nuclear charge itself, the charge of the nucleus, is just the number of protons. Now, it's a little bit more complicated than just the number of protons, okay, because the number of energy levels can also affect it. And that's where the rows come into it, being in different rows. So as we go down the periodic table, what happens is that radius increases. That's because you're adding energy levels. So if we look at the next few elements after oxygen, so this is oxygen here. If we look at fluorine would have 1 more electron, but also 1 more proton. So it would shrink, okay? And then neon would have 1 more electron, but also 1 more proton. So it would shrink even more. But then with sodium, we are adding another proton. Sodium has 11 protons, more than all of these. Yet it's going to actually have the largest atomic radius of any of them. And that's because it has one more electron, but that additional electron is going into a new energy level. And so that's a factor as well. So even though sodium has a larger nuclear charge than oxygen and fluorine and neon, it doesn't have a greater effective nuclear charge. Because effective nuclear charge is sort of a combination of the number of protons, but also kind of how many energy levels there are and how far away the valence electrons are from the nucleus. As a rough approximation, you can calculate this as the number of protons minus the number of core electrons, which core electrons are just the inner electrons, the ones that aren't your valence electrons. Okay. So sodium has 11 protons, but because it has that third energy level, 10 of its electrons are core electrons. So its effective nuclear charge would just be like 1. Whereas neon only has 10 protons, but again, its Bohr model would look like this. It doesn't have a third energy level. It has a second energy level. Those are not core electrons for neon because that's its outermost energy level. So it just has 2 core electrons. So its effective nuclear charge would be 8. So that's kind of what effective nuclear charge is, and that explains that's one of the factors that explains the trends in atomic radius.